Okay, in this video, I'm going to tackle the triangle problem. I will go through the part that I've gone through in class, but I'll also go through the extension in some details. I've drawn three triangle numbers added to another triangle number that's the same and showed it as a rectangle. I've done what I will call T2. T2 means the triangle number which is two squares down and two squares across. And I have not done T3. Who knows why? I've done T4 and T5. And what happens when we add another triangle which is the same size to itself? Okay, these two are the same. This is a T2 and another T2. They're just flipped. The orientation is slightly different. So when they're put together, they form a rectangle. But the rectangle is not a 2 by 2 square. It's a 2 by 3 because of the way they fit together. Similarly, for two T4 triangles put together, they form a 4 by 5 rectangle. And you can check this for any number by simply drawing it or thinking about it. For a T5 triangle, that is, it goes down 5 and across 5. If you superimpose another one onto it, you add another one onto it, you will get a 5 by 6 rectangle. And we can see, right, this blue triangle is the same as this red triangle, just flipped. It's exactly the same. Okay, so we start to see a pattern. And if we think about it, it works always. If we have a T10, which is 10 down and 10 across, if we add another T10, we'll get one extra square going across, and then another 10 up. So we would get a 10 by 11. It'll always work. And we can sort of see a pattern emerging. Okay, so if I do a T4 plus a T4, I get a 4 by 5 rectangle. If I do a T5 plus a T5, I get a 5 by 6 rectangle, etc. So if I do a Tn, n is any whole number plus itself, I will get an n by n plus 1 rectangle. Yeah, this is our rule. And this rule will come in handy later. Okay, the next part of the question asks us, how about if this triangle was 250 down and 250 across? And I had two of them. So this triangle, you can just imagine it's small steps, right? Plus a little bit more, remember? And another one, this triangle exactly the same, it fits together perfectly, as you can see. If this was 250 and the red is 250, how big is the rectangle? And we know it, right? We know it. If T 250 is what we're trying to find, then T 250 plus T 250 would be 250 times 251 would be the dimensions of the rectangle. That's the answer. T 250 plus T 250 equals 250 by 251 rectangle. Answer. Now, the next part of the question is, can you use this to work out how many squares are in the triangle of T 250? Think about it for a sec and pause the video. If we look even from our early examples, there are 6 boxes in the rectangle and 3 of them belong to each triangle, of course. For T4, there are 20 boxes in the rectangle and 10 of them belong to each triangle. Triangles are the same size. The triangles are always going to be the same size. So for this rectangle, there will be half. Half of the boxes are belonging to the red triangle, and half are belonging to the blue triangle. So the answer to the question, can you work out the 250th triangle number, is what? Half of this. Right? This answer. Use your calculator to work it out, but that's how you do it. Now let me use my calculator. 31375. So our real question here is essentially, for these numbers, is 2 times this number the same, equal to 2 consecutive numbers times together? Let's call it n and n plus 1. If these numbers can be found, then yes, it's a triangle number, because that comes from our solution to what is a triangle number, right? This is what we have to find. How do we get to here? Well, we times this by 2 and we square root it. After we square root it, if we think about it, this is square, right? N times n. So to get back to n, we square root, right? The square root does not give us the exact midpoint between n and n plus 1. It does not give us the midpoint. So it won't be, n plus 0.5. Or yeah, it won't be n plus 0.5. But it will put us in the middle, in between the two numbers. Not right in the middle, but in between. So then we'll know what our two numbers should be. Make sense? Okay. Let me show you why. So for T3, right, it's got 3. 1, 2, 3. Its rectangle has 6. Yeah, as we times it by 2. Its rectangle has 6 squares. Now, the square root of 6 is between 2 and 3. So then we reduce that to find, okay, it's 2 times 3, and work out. Similarly, this 4 by 4 triangle, T4, has 10 squares in it, right? 10 squares. Times by 2 gives 20, gives the rectangle. If I square root 20, I get a number between 4 and 5. How do I know? Because square root of 16 is 4. Square root of 25 is 5. So square root of 20 is between 4 and 5. 100%. Similarly, let's just do another quick check. For the triangle 5, which goes down 5 and across 5, it has 15 squares. 2 times 15, 2 times number, gives 30. Gives our rectangle 13. The square root of 13 is 5 point something. It's between 5 and 6. How do I know? Because square root of 25 is 5, square root of 36 is 6, so square root of 13 is between 5 and 6. Okay. So we have our method. So first of all, we want to do 2 times these numbers, square root them, and check for which whole numbers on each side of the square root decimal multiplied together give the actual answer. Let's work through an example or two. Okay, so this is what you end up with after you times by 2 and then square root. And you can see that actually a lot of the numbers are close to 0.5, rather 0.499. Okay, so then for this one, we would do 98 times 99 and see if it equals this. If it does, then this is a triangle number. Okay, and these are the answers that you get. I forgot to mention that you have to divide by 2 to get the triangle number, not the rectangle number. But we can see that this one is equal. This one is not equal. This one is equal, this one is equal, and this one is not equal. So these three are triangle numbers with dimensions. The rectangle has dimensions 98 and 99. This one has 85 and 86, and this one has 123 and 124 for the rectangles. So the last question is there a triangle number which ends in 000? This is actually very simple. Of course there is. Of course there is, right? I can choose a big enough triangle. So for example, if I choose a triangle that's 10,000, if I choose T10,000, I have this formula for the number of squares in every triangle number. I know this, I solved it before, I found it by myself. We found it by ourselves. So if I choose T10,000, then I can work out the number of squares which are in that, and I'll get 10,000 times 10,001 over 2, which is this number over 2. No, over 0. It's this number over 2. Yeah. And then when I divide that by 2, I get 50 and 50 with 3 zeros. And so that's solved. Can you get a number with 5 zeros at the end? Yes, you can if you choose a big enough triangle. Actually, this part of the question is not difficult. So, let me know how you got on with it in the comments or on lunch break or in class. And yeah, keep working.